welcome to this video on area of a triangle at National 5 level. To find the area of any triangle, you'll be given a formula in your formula sheet at National 5, but I'm going to derive it here for you just to show you where it comes from and how we can work out the area using two sides and the angle in between. So here we go. First thing you have to do when you've got a triangle is label all the sides and all the angles. So I've labelled angle C here and angle B, and this is angle A that I'm just going to label here. The next thing you have to do is label the sides. Now by convention this is how we label them. Here's angle A, so opposite that is small a, that's the length small a. B, opposite the angle B is small b. And opposite the angle C is small c. And that's how we label these angles, okay? And it's important that you do that at every step when you're in an exam. First step, label the triangle. So, how do we come up with the formula that you'll be given at National 5? Well, this is how we can come up with it. From National 4, you should know the area of any triangle is a half the base times the height. And that's National 4 level, or even first year. Some people do this in first year. So, what happens, we don't know the height here. We don't have the vertical height. Well, the vertical height will be from here, B, straight down, in such a way that it makes a right angle, both of these sides here. Okay, and if we do that, then we need to find an expression for h, because we don't have the vertical height here. So how do we go about that? Well, using a wee bit of SOHCAHTOA from National 4, then we should know, if I talk about the angle at C here, so I'm looking at the angle at C, well, SOHCAHTOA tells us that sine C is equal to the opposite here. Now that's h, the vertical height h, divided by the hypotenuse, which is A. If we rearrange that, then we get h is equal to A sine C. And plugging that into the formula from National 4, it gives us a half AB sine C. And this is the formula that you're given at National 5. Okay, so if you look at any National 5 past paper, you'll see that formula, and that says the area of any triangle is equal to half AB sine C. Now that's when it's in this configuration. There is another two versions of it. Say we're only talking about angle C here. Say we're given angle A. Well, angle A then, sine A, again would be the hypotenuse over this time, it would be C. So here's the hypotenuse here for this one. We're talking about this triangle here with the angles at A, and that would give you C. And we can rearrange that, and that would h is equal to C sine A. So the area this time, another version. So this is version 1, and that's the standard one that we get in the exam. I'll put wee asterisks there because that's the one you're given. But another version of it is a half. Well, this time the base is B and C, so it's a BC sine A. That's another version of it, because h this time is C sine A. Okay, that's another version, but you're not given that one. Okay, they just give the one version, and you've got to be able to manipulate and remember how to do these things. Okay, the other version you get, I won't bother going through all the details here, but if we talk about angle at B, then we can show that the angle at B this time, area is equal, so we're talking about this angle here, would be a half AC sine B, and that's another version of it. Now I don't remember these versions, to be quite honest with you, because there's an easier way to do these questions. Well, in my opinion anyway, there's an easier way. Now, I tend to stick to this idea, the one you're given in an exam. But if you look at it, then the formula consists of A, B, angle C. So that's A, B, in angle C. Look at this one here. Then at A, angle A, it's BC at angle A. And the B version of it, it's angle at B. Then the version this time, if you look at it, AC, angle at B. So there's a pattern to it, and that's why they only give you this one. And then they try and manipulate all the letters to try and confuse you. Now, the way I like to remember it is I use SAS. Now, SAS is going to be very useful for you when it comes to cosine rule, which you'll do later on. So SAS, but what do I mean by that? Well, to find any area of a triangle, it's half the two sides, sine of the angle. Okay, so to be able to work out the area, we need the two sides and sine of the angle. So to me, that's a really good way of looking at it. So if I know that and know that and know that, then I can find the area. If I know this angle and the two sides, I can find the area. If I know the angle here, two sides, I can work it out. Okay, and it's half of SAS. So that's the way I like to remember it. Might confuse some people, but as long as you know side angle side, then we can work out the area. Okay, so that's me finished with the wee derivation. Now I'm going to be using this idea all the time because this is one that is in the exam. So let's look at a couple of questions based on what we've got. Now I've just taken past paper questions and we're going to look at how to work them out. Okay, so let's look at this question here, and I'm actually going to draw it out a little bit better. That diagram's not great compared to what I can see on my computer here. So we're given an angle something like this, okay, meant to be straight lines, and we're told in the question that we're going to label it PQR. So let's work it out. PQR. And other bits in the question, well, let's label it first. This is small q, this is small p, small r. Remember, you always label the triangle first. So we're given PQ, so the length PQ is given by 5, and that'll be centimetres, and PR is 6 centimetres. Okay, we'll just rub that out a wee bit, put R here so I can get centimetres in here. And we're not given an angle, but we are given the area. Now the area of this triangle is 12 square centimetres. Okay, so that's what we're given. I'm not sure what past paper it is, just got one in front of me, but I don't know what paper it actually is. And the question is, find the angle. Okay, so we're to find the angle, and the angle is QPR. QPR. Okay, so remember from first year, this is where your actual angle is. Centre letter tells you. So this is what we're trying to find. Well, from information we've just derived there, this is the formula given in the exam. So let's write it out. Area equals a half. Now in this case, because it's not A, B and C, you've got to make sure you use the right letters. So that's going to be Q, a half Q, R, sine P. Okay, and we're trying to find P here, sine P, so we're going to try and find C. Sorry, P. So let's put in the information that we know. Well, we know that's 12. Area's 12. A half, we know what Q is, remember. Finding the area when it's side, angle, side. So that's going to be a half times 6 times 5 sine p. So rearranging all this, so let's try and rearrange this. Half of 6 is 3, 3 5s are 15, so that's going to be 12 is equal to 15 sine p. So rearranging it all, changing the subject over to sine p. Sine p is equal to, well, that's going to be 12 over 15. Now lots of people make a mistake here and they put 15 over 12. Now there's a nice wee thing to remember here. If you do 15 over 12 and you put it in your calculator, you're going to get an error when you do shift sine of 15 over 12. It gives you an error. That means you've got these ones the wrong way round, so swap it round to the proper version. So final answer is going to be p is equal to shift sine in my calculator of 12 over 15. So p is going to be equal to, well, I'm just going to do that in my calculator. Shift sine 12 divided by 15, close bracket, approximately 53.1 degrees. Now, if we look at it, that can't be right, okay, because this angle here is greater than 90. So, from your knowledge of your trig cast diagram, just put it here, then sine's positive in the second quadrant and the first quadrant. Now we've found the first quadrant, 53, but we need the second quadrant, so p is equal to 180 minus 53.1, and the actual answer, the real answer, the final answer, is going to be 126.9. Now that was a very difficult one there. Should have realised that this angle was going to be greater than 90. Some people probably haven't done that yet, they haven't done the cast diagram. If you've not done the cast diagram, don't worry about it. You will you come across this, but it comes up in the exam, and it was just one I picked there, so it's quite difficult. Okay, so that's that question, and that will be worth a lot of marks in the exam. That's not a very easy question. I would imagine that's worth about 4 marks in your exam. Now I'm going to pick another one. Hopefully I'll pick another one that's a wee bit easier. So let's have a wee look. The next question. Right, yeah, this one's going to be a lot easier. Now, again, I'll draw out the diagram. And something like that. And it's labelled A, B and C. Okay, and we've got a shaded angle at B here. And what else are we given? We're given this dimension from A to B is 9. So this is 9 centimetres. And the other side is 14 centimetres. So let's label my diagram as normal. That's A, that's C, and that's B. Now again, they give you this formula in the exam, that's your half AB sine C, but it's not that what we want, because we're talking about this angle here, and this angle here is B, so it's this formula we've actually been using. So just got to be careful with that, so that we know what we're talking about. Okay, so to find this angle here, we're given the area in the question is equal to 38 square centimetres. Now we can see this angle is less than 90, so we won't have any problems like the last one there. The last one was really quite tricky. So let's see what we do. Well, the area is equal to, well, it's going to be a half. 2 letters here, SAS, that's AC, sine B. So what we asked to find? We're asked to find the angle at B. So we have to find this again. So the area was 38 and it's a half times 14 times 9 sine b. So half of 14 is 7, 7 nines are 63. So we've got 38 is equal to 63 sine b. Rearranging that like we did before. Okay, we get that. And b is equal to shift sine 38 over 63. And we just simply work that out. Again, just use my calculator. Got to be quite a small angle. It should relate to the diagram. So shift sine 38 divided by 63 is equal to 37 degrees approximately. 37.1. A lot easier than the first one. Okay. And that's how you go about that. Okay. I'm going to try and find another question that's maybe a wee bit different. So let's see if we can find something that's a wee bit different. Yeah. Here we go. Here, this time I'm going to show you one that's non-calculator. So you won't have a calculator for this question that's coming up. And you have to work out the area. Okay, so if you've not got a calculator, then the numbers should be easy, or they should give you enough information to make it such that you don't need a calculator. So here's my triangle. Again, not the best triangle in the world, but there we go. And we're given 10 centimetres here. We're given 12 centimetres here. And we're told in the question that sine b is equal to 2/3. Okay, so that's sine c is equal to 2/3. Okay, and we have to work out the area. Well, again, you've got to be clued in. Let's label the diagram. That's small a, that's small c, and this down here is small b. Okay, and we know this angle in here, sine, we know sine of this angle, we're told this in here. So again, this could be confusing in terms of if you look at your formula sheet, you're thinking of this one, but we know sine b, so we have to use this version of it. So it's the third one we did there. So the area is equal to a half AC sine b. So my area is going to be a half, two sides that we know, which are 12 and 10, times sine the angle, which is 2/3. Okay, I should swap these round here, just technically. That should be the 10, and this one should be the 12. So just in case I'm confusing some people here. So what does that give me? Well, that gives me the area then is equal to half of 10 is 5, 5 12s are 60. So that's 60 times 2/3. Well, 2/3 of 60 divided by 3, which is 20, times by 2 is 40. And that's square centimetres. 40 square centimetres. Now, that's a paper one. You were not given a calculator for. You expect to do that without a calculator. And the reason we know that is you're given this bit here. When you're given sine of an angle, a value for that, then you know it's non-calculator. So that's a wee thing to try and remember. Okay, let's see if we can find another one to do. Okay, there's ones that are a wee bit harder, but I don't really want to go to that level. Yeah, here's another one similar to what we just did. So let's draw the triangle. Okay, so we're given something like that, and we've labelled it P, Q, R. and we're told that this side up here is 20 centimetres and the other side is 16 centimetres, and we're told in this question that sine P is equal to 1/4. 1/4 it is, 1/4. Okay, so this is angle that we're talking about, sine P, so we're talking about that angle there. Again, non-calculator, because we're given sine P, we don't have to work that out. So we're given that. So what's my formula then? Well, let's label small p, small q, small r. So here we go, the area then is equal to 2 sides in between the angle, so that's going to be a half QR, and sine of the angle, which is at P, and we know that already, and we know Q and R, so we can work out the area. So it's going to be a half, Q is 20, times R, which is 16, and sine P is 1/4. Sine P is 1/4, so it's this bit here that's 1/4. Lots of people make the mistake in the exam, they put sine of 1/4 and they get all mixed up. Okay, so let's work that out. Half of 20 is 10. 10 times 16 is 160 times 1/4. Oh, and the answer comes out to be 40 square centimetres again, just like the last one. Okay, so I think I've done enough there on the area at National 5 level and some past paper questions to show you. First one's pretty tricky if you haven't done the cast diagrams yet. That's more trig. Sometimes that's done at the end of courses. I know a lot of schools do it at the end, so don't worry about that one if you didn't get that one, but the rest of them should be fine for you. Okay, the next video I'm going to do is the sine rule. Okay, so that'll be my next video.